Welcome, everyone, to the Capsule 21 podcast. I'm Middlemarch. Tom Lehman is my name in real life. I'm joined by my co-hosts, Piv and Dovetail. We are the Capsule 21 team. Capsule 21 is an art collective centered around the appreciation, the celebration, and the creation of timeless art using blockchain technologies. And we have a podcast, and we've covered a variety of topics, but today is an extra special episode because we are with a true on-chain blockchain luminary. His name is CX Coda. I know his real name. I'm not going to say it. Or I know a name that sounds more real. I'm not going to say it. But what I will say about him, and we've talked about it before, he's been already in the game. But I will just say that recently he has put out something which has really reinvigorated me about on-chain. If you know something about me, you know that I was very passionate about on-chain stuff and the potential for the blockchain to enable timeless art. But I became deeply skeptical of it and began to hate it and think it was actively bad. And it was a very depressing period. And now CX Coda has come and reinvigorated it. And you'll find out soon. He was a former. Well, anyway, I want to look up a quote about this, but just let me say, welcome so much. And also, we're going to learn about equanimity and dealing with haters. So this is going to be a wide-ranging episode. Let's start with just a welcome. CX Coda, how are you doing?
Hi. Pleasure to be here. Thank you for inviting me. I am very good. It's almost the weekend. How can you not be good?
Yes, happy Thanksgiving to all the Americans and everyone feeling the vibe. And I think it's probably broader. I had a very nice Thanksgiving celebration. Piv, Dovetail, we were just talking about. We have a lot of time zones represented today. Piv, Dovetail, Piv. We had a very extra. There's two podcasts this week, so you have to listen to the other one as well. But now we're feeling warmed up and ready to go. Piv, Dovetail, how are you feeling?
Yeah, very good.
Oh, go ahead, Piv.
I think we had more time zones yesterday, but still for the other podcast, and quite diverse. I think yesterday it was really art centered. And now it's more technology-centered, can I say that?
Yes, Dove is always trying to keep us honest with
Yeah, and I'm doing good. I was disappointed that I had to miss so much of yesterday's pod. I had to go do some Thanksgiving things, but like the first half an hour that I did catch seemed really interesting. Like I liked what Burke had to say. Like I have to, as soon as that's on Spotify, like I'm gonna go listen to the rest of it.
And so that's fantastic. Okay, so to frame the situation, I finally found this quote. I should have looked this up before the thing. If you ever think of it, and I didn't know C.S. Coda was a former academic, but I am a great, I'm not a scientist academic myself. But I'm a great big believer in this book called The Structure of Scientific Revolutions, which is about how science isn't, all cracked up to be. And there is a great quote in it, which I love, and I think applies to this current situation. I'm just going to read it. This is a quote from physicist Wolfgang Pauli, who came up with a bunch of stuff. And he said, this is in the early 1900s, at the moment, physics is again terribly confused. In any case, it is too difficult for me, and I wish I had been a movie comedian or something of the sort and had never heard of physics. And then it goes on. This is the book writing, the Scientific Revolutions book. That testimony is particularly impressive if contrasted with Pauli's words less than 5 months later. Here are the new words from Pauli. Heisenberg's type of mechanics has again given me hope and joy in life. To be sure, it does not supply the solution to the riddle, but I believe it is again possible to move forward. And this is this big turnaround. And I think this is amazing because CX Coda, academic, and also this describes my experience reading his tweets surrounding the Moonbirds in chainness. And so that is the framework, going from total despair to total elation. That's what I felt. And so with that, I would just love to jump right in and talk about just this process, how we ended up here, and the equanimity with the haters. Let's do it. Moonbirds on chain.
First, thanks for comparing me to Heisenberg. That is really an honor.
And me to Pauli. I'll do that, but I want Pauli. Okay, go. Yeah.
So how we deal with the haters? I mean, they are only partial to blame, I guess, because like to be totally fair, our messaging was a little bit confusing. I mean, we could have done really a better job there. So I mean, this is something where we can really learn a lot from, how to like blend together, like how to better like incorporate marketing and technical engineering nuances. Because like our biggest mistake, I guess, was that we like introduced a new term that people were not familiar with and said it in the same sentence as the innovation part, which are actually totally different concepts or totally different aspects of the project, but people started to think that started to misunderstand that we were trying to say that like we invented ink chains, so sort of, which we didn't. There is a lot of other already existing projects that fall into this category. We just like try to establish a new word because like on-chain, the term itself is so confusing and so loaded. And yeah, so that is the problem. And like there was a lot of misconceptions out there, and they're only like partly to blame. And we have a lot to learn from that, actually.
I think that is an amazing POV. So why don't we jump back to really understand it? Because I think the term in-chain, Piv was sort of, and I were talking about this, and he wasn't so familiar with all the details, but he definitely knew, like, oh yeah, the in-chain meme. So that became a meme. But like, before we get it, like, how did that come about? Like, maybe just take us back. Like, I dug up an old tweet of yours from, maybe it was like August or September. You said, okay, I'm going to work for Proof. And even when I saw that, I was like, that's kind of interesting. But can you just kind of like, what led to that tweet, you working at Proof, and then tracing the path to here, and then the in-chain aspect and everything? Like, how did this all evolve?
Okay, so my whole journey more or less started 1.5 years ago, probably. So yeah, summer last year. And this is when Aaron from Divergence and Harry, they started their Broadchain project. And Broadchain was like the Mandelbrot fractals, but rendered using nothing but smart contracts. And I was fascinated by that. And I thought I wanted to do something like that myself, because I got so intrigued with how that works, and that everything is stored in the blockchain and there are no external dependencies whatsoever. And I just thought to myself, I have to do this as well. And this is what, or even before, when I was working in academia, I was doing computational physics. So like most of the day, I spent my time with solving differential equations, which is like basically a mathematical framework to describe dynamical systems, like how an atmosphere evolves, how a ball rolls downhill, stuff like that. You can all put that in like differential equations. And I spent my day treating those type of equations on the computer, actually simulating them. And since I was already so familiar with like how to realize that on the computer, I thought to myself, well, this is the prime example, or the prime like thing that I can put on the blockchain, because I'm already so familiar with what I have to do that I can more worry about how to just translate that over to the blockchain. And that's just what I did. And I ended up with my Strange Attractors project, where I basically simulate like a bunch of different strange attractors or chaotic systems using nothing but smart contracts.
So that nomenclature, strange attractors, is that where did that literal name come from?
That is the type of systems that we have here. So all these chaotic systems have a so-called strange attractor. So the term originated from it was Edward Lorenz. He was a mathematician and meteorologist, and he studied atmospheric conditions, or he had a really simple model for the atmosphere. And what he found was that if he changed his initial conditions ever so slightly, the system tends to evolve completely different. And this is what's also known as the butterfly effect. And which means that like small disturbances in something yield wildly different results. But the atmosphere always evolves within the same like regions, let's say. They always behave differently, but always kind of the same, because like you always have like temperature variation from, I don't know, minus 20 degrees to 100 degrees, something like that. But not like 1,000 degrees or 1,000,000 degrees. So you always have these ranges where it evolves. And this, if you visualize this has a certain three-dimensional structure in his model. And this structure was then known as strange attractor. An attractor because like it attracts the state of the atmosphere, and strange because it never repeats. You will never have the same atmospheric conditions twice. And yeah, that's basically what a strange attractor is.
So that's interesting. Yeah, so this chaotic thing, the butterfly effect, right? I think one thing that is always interested in me, and correct me if I'm wrong about this, like there's like science fiction about this, and I've read the Wikipedia, but like my favorite examples of this, right, is like so you have the gravity, right, and you have two body problem. You can see you have two things out there, and then gravity affects them, and you can predict where they're going to go, and whether it's going to be like they're orbiting each other, or they diverge, or go everywhere, and you can kind of predict that. And then you put in the third body, which is creating what's called the three-body problem, which nerds out there will know, a lot about. Three-body problem. And obviously in real life, there's n bodies because they're all over the place, but like in a localized place, 3 bodies. And then you go from 2 to 3, and you go from predictable to total butterfly insanity, where you cannot predict what will happen in advance. And is this an example of what you're talking about?
You can always predict what will happen. That is the case for both types of equations or types of systems. What you cannot do is determine the initial conditions exactly enough to like simulate it, because like if your initial conditions, the ones that you measure, so the position, for example, of the planets, will always have a slight error. You can never really measure it down to like the infinitesimal position after the comma. You will always have errors in your initial conditions, and those slight changes or those slight errors will at some point become dominant. That is the whole point why it evolves chaotically, because you can never really have the initial conditions.
So that it requires too much measurement precision, whereas in the case of the two-body problem, it still obviously will create errors when you can't measure it precisely, and you end up computing based on the wrong measurements. But there's enough room for error where you'll basically be able to see the results that your model predicts.
The difference between the 2 and the 3-body model is that the 3-body model amplifies those slight deviations or those slight errors, whereas the 2-body problem keeps them kind of the same, so you never see the changes accumulate. Whereas like for the chaotic systems, they get bigger and bigger over time until you have a system that looks completely different than what you would expect.
Got it. But when I'm on the Wikipedia page, and let's not talk about this because this is truly like nerd, not even that nerd. It says, okay, there's no closed form solution, right? So there,
exactly,
is that relevant here? Like the idea that you always are going to be dealing with some like series or something like this, or is it really just like, the point is, whether it's closed form or not, you can use some approximation to compute it to arbitrary precision if you can trust your initial measurements, is the idea. So the fact that there's no closed form is not like that interesting, maybe, is the idea.
No, there are other problems that behave much more mildly, let's say, and also don't have a closed form.
Got it. And is that property, the fact that the system magnifies errors, is that kind of like a property of systems? Is that like the thing or one of the big things that describes this butterfly effect thing, that the system itself magnifies errors in the measurement of initial conditions? Is that kind of like a simple way to say like...
Yes, that you can put it like that simply, yeah.
So that's amazing. Okay, so then everyone out there, butterfly effect, people know about. That's how you should think about it. That's a great thing, where it's like there are always going to be errors. The question is, are those errors going to get bigger, smaller, or stay the same as the system evolves through time? And if they get bigger, you're in some real trouble as enough time passes. Okay, cool. And so then the images of strange attractors, which I can't easily put in the nest here as I talk, but I'm looking at, it's very beautiful. It's on OpenSea, 0.275 ETH in volume. So you have to decide yourself, are you serious about chaos to buy it, but not so bad. So the images here are chaotic in the sense that so the images you see in this project are chaotic essentially, and is that right?
Yeah, exactly. So basically, each image is a totally individual simulation of one of these systems with different starting values. And when you simulate that, what you basically get is a 3-dimensional curve. And what you see on OpenSea is a 2-dimensional projection of that 3-dimensional structure. And what you as a holder can do is rotate that structure in 3 dimensions and like basically change the 2-dimensional appearance of your system.
And that's free?
Yeah, that's free. I have a tool on the strangeattractors.art website that holders can use to rotate their attractors. There's also a demo that you can use if you don't hold anything.
Very, very, very cool. And so this was your first project, basically.
Exactly. That's how I got hooked on the whole in-chain thing, because like all the simulations and all the 3D manipulation stuff is really done in the smart contract. And also the rendering of the final vector graphics is all done in there. And yeah, that was kind of my debut project, the first big thing that I did. And from that on, I started doing smaller gigs as a contractor, basically. And yeah, then at the beginning of this year, I think we started working on the GM Studio. Have you heard of that?
I don't think so. What is that?
It is a Gen Art launch platform. So similar to what Artblocks and Gen.art and all the Gen Art platforms out there are doing, but with two major differences. So we're in the GM DAO, we were a bunch of like tech enthusiasts and artists and all like people from the scene, and they were kind of like fed up with the Altblocks bias, because like if you're an artist with a big name and you go to Altblocks, you will immediately get curated. And people were really annoyed by that. So we said, yeah, let's launch a new platform that does like completely transparent and blind curation. And that was one of the first thing. And the second thing was that we did not want this platform to benefit a few people, but all the revenues go back to the DAO, which are then used to fund other projects from within the DAO.
Oh, very cool. So this is Artblock's model in terms of like the technology where the contract gives you the seed, and then the JavaScript comes into play and then renders something like that, like the fundamental flow of that was the same?
Exactly. It's really similar to that, but with the exception that we set up our things with much more modularity, let's say, that enabled us to do the first processing project that is launched as GenArt as on-chain GenArt, let's say it like that.
Could you describe a little bit more what you mean by that?
Processing is a library that is a Java library basically, but all the other platforms only support JavaScript and WebGL and that type of stuff. And we since we have a modular backend that does the rendering for us, we're also able to incorporate like processing and Java native things into that.
And so, okay, that's interesting. Like my sorry, go ahead.
No, go ahead.
I was just gonna say, like, if you're the Artblocks mechanism, right, is that this thing gets delivered to the browser, and it has some stuff from the smart contract, in most cases just like a little number, and some stuff from just like a JavaScript stored on some server. That JavaScript could be stored in the smart contract too, which would make it more pure in some ways. But the idea is your browser, and this is going to be a theme in this conversation, like your browser has to do this heavy lifting of figuring out how to turn what is essentially text. JavaScript is text, basically, to turn the text into an image. But with Java, and those of you who are in the more millennial range, remember there was something with Java in the browser once called an applet, which was basically a gray box that was in a web page. But if you're rendering this through the browser, then how can you use Java?
We are not rendering it through the browser. We have a dedicated end backend that does the rendering for us, and we have that embedded with just as an API call, basically.
Got it.
It's on-chain in the sense that it is like just the code is stored and archived on-chain, that if anyone wants to recreate it, they can download the code, execute it again on their computer, and regenerate the out from that. And I am using the term on-chain deliberately here because that is what on-chain means to most people. That code is archived on the blockchain, but not executable.
So the idea, just break it down. So you have a website somewhere, a server running on some platform, and that server gets a request for an image, right, from OpenSea. That server queries the blockchain, gets code and data, and just data maybe, or gets something, and then can, makes an image from that, and then spits it back and gives it to OpenSea. And the idea is the code and the data, all that stuff is stored on the blockchain. And so if you don't trust this server, you can always create your own server and achieve the identical results without any additional special information that comes from your brain, because the details, the nuts and bolts, are all in the blockchain. Now, of course, provided you use the correct version of all libraries and the JavaScript, the Java and everything. So that's when it kind of gets, more interesting, where it's like, anyone actually trying to reproduce someone's results, even your own results, it's like a, it's not necessarily an easy thing to get to a web server. There's no, from my experience, easy copy paste, especially if you're not using the latest versions of the packages, right? So, this is on chain. So when you say on chain, and I don't think I would argue that you are not, when I think today, when people think of on chain, they think of something where, the token URI spits out, some complicated, looking base64 thing, and that's enough. I think art blocks, even though it's quasi on chain, because the API, the token URI spits out some gross API Web 2 thing, doesn't look so on chain. So when you say on chain, what do you mean, and how is this project on chain specifically, the one we're talking about now?
Exactly that. Like, we are just storing all the necessary information that is needed to reproduce the images. We archive that information on chain. It being the seed number, so the random seed that goes into the generation, and the generative program or script itself. That is all. And like through that GM Studio, what I learned there is that a lot of people there calling this on chain, because they are so used from art blocks to call this on chain that already means on chain to them. And that was kind of like, how do I put it? This always bothered me, because like, to me, on chain is also something else. This is why we opted to call it something else, because like, truly on chain stuff is rendered in a smart contract, which is not the case for art blocks and GM Studio and what other things. That's how we decided to call it something else, and we used in-chain for that in the end.
Got it. And I had heard the term in-chain and also didn't like it, unfortunately. I get what you're saying. I had heard the term in-chain before this, but you put it on the big stage and got in a lot of trouble for it. But I do think, even though I don't like that term, just because it kind of like, I don't know, I get the haters on that, but I do think it's worth calling it something else, because the other thing really is not good. And the way I always think about it myself is, it's like, there's code and there's data, right? And it's like, they're not different, philosophically speaking. And so if you put something that's code, if you put data on chain, that's so expensive. So let's just put code on chain. But putting code on chain is the same thing as putting data on chain, because you need, the logic to render that code, and that has to be existing in some package, and that's data, and that takes up space, and Google Chrome is really big. You can't put that on chain. So, JavaScript that needs Google Chrome to render is not really on chain. It's fake on chain, because it is relying in a subtle way on something else. And so not good. And so, okay, so that's kind of a good place to jump off. So what is the good one then?
The good on chain, you mean?
Yes, the good one. Yeah, good on chain.
There's also nuances to that. So for me, the good on chain, the true on chain, is what we are now calling in chain, which means that the generative script or the generative program, the algorithm itself, is coded in the smart contract itself. So all the heavy lifting is done by an algorithm that can be interpreted by the Ethereum virtual machine, essentially. So we have a program that is like interpretable by the blockchain itself, or like the execution layer of the blockchain, and we have also the data that is fed into that algorithm is also stored on the same blockchain. So we have this like one place where we have everything that is needed to generate the image, and it can also be executed there, and we don't need anything else to do that. Right.
But philosophically speaking, you can kind of drill down into this a little bit, right? Which makes it interesting to me, where it's like, if you can go to Etherscan, you go to the token URI, or maybe there's a function called token bridge, you get token image, and then you see a bunch of base 64. You don't actually see something. This is what a lot of people have to think about. On Etherscan, you don't actually see the image, right? You just see base 64 text.
Yeah, exactly.
So
you need a base 64
something
decoder.
has to happen. Yes, you need a base 64 decoder.
Yeah.
And then even if you do a base 64 decoder, I mean, good luck looking at that with your eyes, because, we are most, used to, ASCII, and then there's Unicode, which is, these are all representations of bytes using like whatever you want to call them, glyphs or runes or whatever. And Unicode is like not everything. So, you can't even look at this thing once you base 64 decoded it. There's no reasonable way to interpret it as text. So now you're looking at this garbled total mess. That's not an image. That's worse than base 64. That's not an image. So then you need to do something else.
Exactly. Yeah, I totally agree. I mean, that's what I meant with there is a lot of nuances to these discussions, because like philosophically, you can regard everything as dependency. Also, like you need a connection to the blockchain. This is a strong dependency. Then you need a display. Then you need a computer to actually do something with the data that you get back from the contract. And there's a lot of like different levels of dependencies, let's say. And like relying on something that can interpret JavaScript, for example, to me is a much stronger dependency on externalities than, for example, a base 64 decoding, because the latter is so standard and is so like well documented that you can basically do it on a sheet of paper if you want.
Right. And also it is a process that is, I think, unless there's a problem with the way it's specified, it's guaranteed to terminate, at some point, right? Like,
exactly.
Out there,
exactly. Yeah.
With the JavaScript thing, you never know when you're done. It might continue drawing pixels forever.
Exactly.
And then what do you do? And that could be actually really artistic, some people would say, but it's a different type of art. And, your computer obviously is finite. So you're in trouble there if it lasts forever.
That is a good point. I've never actually thought about it in the context of the halting problem. But that is an interesting point of view, because like with the JavaScript, you can never guarantee that it will terminate at some point. Whereas
exactly.
with base 64 or a bitmap, I mean, it's guaranteed to stop.
Exactly. And I think this is,
that is a good point,
usually this type of thing is exclusively for nerd stuff, but I think it actually is pretty relevant in the case of something like JavaScript, which, literally you do end up sometimes with JavaScript that like runs, that's, oops, it's crashing my computer. It's running forever. It's not, there is bad behavior there. Whereas, you want to be able to limit the bad behavior to, the art being bad or something like this. So, I am just, JavaScript's this. So here's my question then for you. And by the way, anyone feel free to, it's just like, this is like actually really important stuff. But if it's like a little nerdy, like you can ask questions, like please try to follow along. This is like the whole year of my life is leading up to this conversation. What about SVG? How do you feel about SVG?
SVG is definitely less dependent on externalities than JavaScript. So it's better under those criteria, but it still needs something to interpret it, which is usually a browser or whatever. You need something that translates these like vector instructions into pixels that are shown on your display. And I mean, some people argue that SVG is better than bitmaps, for example, because like it is human readable and you can pull out a piece of paper and just draw it out yourself. But yeah, I mean, I agree for simple things, but as soon as you like have filters in there and other stuff, then it gets really messy. So yes. I think that SVG is fine because like it's also a really good standard. It's really old. It's really well documented, and it's implemented virtually everywhere. But I would argue it's not as pure as a bitmap, for example, because it still needs that renderer.
Agreed, and I think that, and here we get to the point where I put myself in the shoes of Wolfgang Pauli and just say, when I was younger, I got into NFTs in this year, January, and I started, oh my God, on-chain, everything. The same thing that every, nerd goes through here. And it's kind of like, oh my God, I started doing the SVG thing. And then Twitter doesn't support it in the hacks. I said, Twitter's wrong. I'm right. I'm the best. I'm the smartest nerd or whatever. And then over time I became, like Wolfgang Pauli. And I basically said, at the moment, on-chain development is again terribly confused. In any case, it's too difficult for me. I wish I had been a movie comedian, basically, because what I became to appreciate is that SVG is kind of this scam, basically, because it comes to you and it promises one thing, scalar vector graphics. It promises Yeah, human readable, super simple, the simplest, the best. It's literally human readable. You can look at it and imagine what it looks like. It's the most basic thing, infinitely scalable. It's all vector stuff. It feels like this good thing. But then when you start to look closer, you realize it's just, it's like Scooby-Doo. You pull off the thing and it's just, HTML and all the nasty stuff that gets with HTML. So for example, there's something called foreign object, which is an SVG tag that allows you to literally just put HTML in there. So already you're in HTML land. You mentioned filters. So, Dove and I were working on this project called Yunks, which was a sort of nostalgia punks, like a CryptoPunk nostalgic derivative, and it had a rain filter on it, which was achieved through the FE turbulence filter, which is basically a way to kind of do cloud-like stuff, make a cloud-like image in an SVG. And, there's just an inherent chaos in drawing noise and drawing clouds, and there's blending modes, and you do this, and it just looks different across browsers. And now you're sort of like, okay, well, if a bitmap looks different across two different renderers, then you say, okay, well, one of them's wrong. One of them has to fix itself. There are probably unit tests that account for this. Pixel by pixel that say it has to do this. With the browser, it's just, hey, we did our best. That's how it works with HTML too. We did our best. Browsers with HTML go so far as to say, listen, whatever you throw at us, we are going to use it. There's a very funny example in JavaScript where, because of a plugin called MooTools, right? Believe it or not, there was something called MooTools that serious people used. MooTools did something with the word flatten, which was a function to make an array flat, to remove all the nested arrays within the array. So they renamed the JavaScript flatten, they named it flat to work around MooTools, right? Which is absurd to me. The point is, browsers do all this stuff to make sure that they accommodate you, which means there are these inconsistencies. So there are those inconsistencies, and then on just the most basic level, you have the same problem as JavaScript. I mean, there's not like you can put JavaScript in there. Most people ignore that, but there's not a halting problem, but there is the ability to have infinite complexity, right? You can say, I want 1 billion circles on the page, or even more simply, I want to put a single CryptoPunk's head duplicated 365 times and 360 times and rotated 1 degree for each duplication. So you end up with like a circle of CryptoPunks layered on top of one another. Piv and I did this with a project, and it's not that complicated to do conceptually or even in code. And yet OpenSea crashes when you try to render it. So you can always create SVGs that are that are artistic, that crash the browser. Not the case with bitmaps. If you want to see the results of 1 billion circles on the page, a bitmap can always just show you that. So I would say that, my feeling about it was that SVG, to me, when it came to SVG versus JavaScript, yes, it's less of a dependency, but it doesn't actually matter in practice. And the Twitter hex is something that really shows this. The Twitter hex is a broader symptom of just complete lack of interoperability with anything that's not a full web browser. And people are always saying, hey, once the Twitter thing supports SVG, we're in good shape. Well, bad news, it will never support SVG, because SVG allows you to put 1 billion circles on something, which is a perfectly valid SVG. So I was really thrilled to see this project, because even you are giving more charity to the SVG than I think it deserves, but you did push it a step further, and you said Bratz did it first, but you were the first to do it when I saw it. So what do you feel about this SVG thing, and how did you take it from here?
Like, just to correct you, Bratz were not the first with the bitmap. There were other projects that were even before. So like, I think the first was a relatively unknown project called Crypto Ghosts, if I recall correctly. And then there was WigaWex Mandalas. And then there was a long time nothing, and then at some point came Broadchain. And
okay.
I think a bunch of other guys did it as well. So we are definitely not the first to do on-chain or in-chain bitmaps. And yeah, so the main motivation why we chose to have bitmaps is one is a technical reason, because we are dealing here with pixel art, which are pixels, and if you want to deal with pixels, why not use a pixel format, which is bitmap? So there's like this natural technical connection. And the second one, of course, is because vector graphics don't work with Twitter. So we had to do bitmaps in the end.
And so this ends up being literal like .bmp sort of thing?
It's .bmp, yeah.
So you're not doing PNG here. You're doing BMP, which is the purest thing, actually.
Yes. No compression whatsoever. It's just a stream of RGB values, or BGR in the case of bitmap.
Sorry, say that again?
BGR. So blue, green, red. It's actually reversed for bitmap for some reason.
What?
Or for BMP. Yeah, it's BGR.
Okay, we forgive them. You heard it here first, by the way, unless you're anyway. So to draw a bitmap, now we're getting into nerd stuff. To draw a bitmap, basically, there's probably, and I know nothing, but I would guess there's some kind of initial header information that says this is a bitmap, and then after that, you basically say, okay, I am going to encode the 3 channels. Let's just call it RGB for people's sake.
For
you got RGB, and that's what is that typically? It's like 16. 2 bytes per color. Is that
no
right?
1 byte. 1 byte.
1 byte per color.
Yeah.
Okay.
Yeah.
I guess that's always how. Okay. Yeah. 1. Right. 0 to 2. Okay. So one byte per color, and then there's an alpha channel too.
No, just
because I guess
RGB.
the final image is no transparency.
Yeah, exactly.
So you just put all the bytes, you write all the bytes out, and then you put the header on, and then you emit that, and then the Twitter thing recognizes it basically.
Exactly, yeah. And I mean, there's really nothing simpler than you can transform an image into. It's really just a series of pixels that have a color. And you can really also look at it and just draw the colors out yourself. I mean, it's going to be a thing. To me, it's much simpler than SVG because it cannot get more simple than just a list of colors.
Wow, that's
basically. Yeah, I
so
mean, you have to know the file format, so to know where exactly the colors start, and that you have these blocks of 3, and you have to know that stuff. But once you know it, you can just go to Paint or whatever, and just click on pixels and color them according to the triplets you find in the file.
So that's incredible.
That's it.
And so if you look at I don't know, one contract that I've used a lot is the CryptoPunks data contract. You familiar with this thing at all?
No, I'm sorry.
So it's basically
yeah,
it's all the CryptoPunks, and you can get the pixels for them. And one way to do it is it actually exposes pixel data, which you can get as just a bytes, as you describe it. But then the easier thing to do is you can get it as an SVG. And the way they do the SVG is they literally just render it out as rectangles. So you end up with this thing with a ton of rectangles on it. And it actually doesn't do rectangles for the background. So the background's transparent. So it doesn't actually match the file thing. But that to me is kind of basically, what you did, where it's the classic model is a rect per pixel in pixel art, if you're doing SVG in the simplest way, and that you might as well just use BMP because it's the same thing, basically. Is that right?
Sorry, now you're cutting out. I think it's my app.
Oh, can you hear me now?
Yeah.
Okay, so I was just saying, the classic SVG representation of pixel art on blockchain is an SVG with one rect, R-A-C-T, that element, one rect per pixel, and it's 1 by 1 or something, and you set the view box to 24 by 24, and then you set the width of the SVG to 1200 by 1200, and you have achieved this. So, basically what you have done is this equivalent process, except instead of rects and SVG, you are using, bytes in a BMP, but conceptually it's kind of the same idea. It's like using a rect, basically.
It's kind of the same idea, with the exception that, so with bitmap, you have this string of pixels, and every position in that stream has a defined position. Whereas with vector graphics, with those rectangles, you also have to define where that rectangle is. And that translation felt really unnecessary and unnatural to me. Why do I have to specify where this rectangle should go if it's really in a nice order?
Right, one after the other. And of course, in the CryptoPunks thing, it does do what you describe, and it just increments the X every time it reaches the end, increments the Y. It's just totally extraneous because it's completely in order.
Yeah.
So, SVG takes another L. So now the beauty of SVG, though, or so good?
Yeah. Sorry. I was just saying this. I wanted to say the same. The beauty of SVG is that you have this infinite scalability, but there can be hybrids. You can also embed a bitmap URI into an SVG to get the scaling. So you're still encoding everything in the bitmap format, which is really natural and technological. I mean, it's really compact, but you get the SVG scaling, for example.
But you don't get the hex.
You don't get the hex in that case. That's why we had to do the on-chain scaling. But if Twitter supported vector graphics, and I was just I would just want to have the scaling, then I would do it with this hybrid.
Right, and you can even do what one of my friends and a great contributor to the space, Michael Hirsch, does with his project Indelible Labs is he actually does basically you upload the traits as PNGs, which are small enough that you don't have to worry about compression, and then it layers the traits together using elements that have background image or something like this. So you can layer the PNGs on top of one another, and so you end with something where it's layers enabled and it has the generative aspect. You don't have to worry about compression because it's already PNG. And it's infinitely scalable for the reason you described.
Yeah.
So I think that that kind of approach, and I really think Indelible Labs is great, and Piv has used that to great effect. I think that kind of approach is really great. And the only problem, of course, is it's not pure enough to be interoperable. And if only there were a way to say, hey, listen, I'm an SVG and I contain only raster elements. I'm purely a shell. I'm a shell of a file format. That would be a great thing to communicate, but. You can't, and I think for also halting reasons, maybe you can't even guarantee you're that, or I guess there's no job, whatever. So the point being, you needed to do scalability, infinite scalability, not infinite, but you need to do scalability,
not infinite, yeah,
and you needed to do it with the BMP format. And so this is where, to me, it gets also even more interesting. And I recall even you saying in a thread that you did it in a way that was compatible with Etherscan's gas limitation, which to me, I saw that I was like, chef's kiss. Like, why? Why do you care about that? Like, you're changing the world. Why do you care about the little people? But you do care about the little people. So can you tell us a little about that?
That was one of the strong requirements for us for the project, because usually when people ask us if a project is truly in chain or truly on chain, whatever term you prefer, we usually say go to Etherscan and just query the token URI function with something and see what gets back. If there is a URL to some Web2 endpoint, then it's definitely not. And if it's some base 64 encoding of something, then you have to look it up what's behind it. And if you get a image encoded as base 64 back, then you know it's truly on chain or in chain, whatever. Exactly, that's what we are usually telling people, and so we had to make it work with Etherscan, because people will check if it returns, and if we have to say no, this runs out of gas because it's so complex, then we'd kind of bite ourselves in the back.
Just sign up for a free Alchemy account and get into your browsers. They can still find it for free, right? Alchemy lets you do it.
Of course, but that's too much effort.
In meme world, the meme is do exactly what you say. So you had to do the memes here. So how did you approach this question with that requirement?
So of course, first I had to find out how much gas can I spend on Etherscan that it is still executable. And I programmed a benchmark contract which just lets me input a number of iterations and just runs a stupid for loop for n times, and then gives me back the number of gas that was consumed. And then I used that to figure out where the gas limit is. I just increased the number in steps of 10, for example, and then I found that the gas limit on the girly testnet for Etherscan is at 500 million.
Really?
So, yeah.
That's amazing. I thought it was 30 million.
No. On girly it was 500 million, and I used that as my value or my limit to work with, and I designed all the contracts around that, and it worked beautifully. And so I called it a win. And then on Tuesday, I deployed everything to mainnet and found out that the gas limits are totally different on mainnet than they were on girly. And that was kind of a bummer. I haven't exactly benchmarked it, but they are way lower than on testnet.
What would you guess? Just to give our audience, hey, audience out there, if you're trying to not get, if you're trying to do a good project here, I thought it was 30 million. Is it higher than 30 million?
I think it is higher than 30 million on mainnet. Maybe 50, maybe 100, but definitely not 500 million.
That's great. Can I use my local hard hat just to get super nerded out here? It's 30 million for me on my local hard hat thing. I got to figure out a way to change that factor because I thought that was the sort of standard.
Forge.
Forge is better than hard hat, basically.
Definitely, it's much nicer to debug and develop it.
Well, it only took me about 6 months to figure out how to use hard hat, and I still don't know. So it's good to just jump into a new, even more powerful and hard to understand thing. But okay, so you needed to basically, all right. So you got some room here. So how did you? So is there an algorithm for this, or like a thing that's just like a meme for this? You can just like look up and copy and paste, or did you have to kind of like, go through the forest and look around, or how did you figure out how to make this bigger? Because like right now, but by the way, it's just setting the stage. You have a bitmap, which is a string of bytes, and it's 48 by 48, right? And that's small.
42.
You want it to,
42.
Sorry.
42 by 42.
Sorry, 42 by 42. I was in the contract. I forgot that. So it's 42 by 42. So anyone out there can imagine 40. That's small. You want to make it how big, ideally?
Ideally, it should be the same resolution as the original off-chain images, which is 1008 by 1008. So a scale up factor of 24.
So 24x scale factor. And so intuitively, just off the top of my head, you look at the first pixel you see, and that's the top left one. So now you make that pixel, 24, x wider. You make them all.
Yeah, exactly.
And you go to the next line. You think, okay, well, I'm not actually on the next line as I used to think I was. I'm on the second line. So I put a buffer. Is this kind of like the idea? Is there a smarter way, or even
no? That is really the idea. So like in on the EVM, everything. So a memory word basically is 32 bytes, and I filled that 32 bytes with the same color basically, and then just used that chunk and copied that around, which is the most efficient way to do it as far as I know. But in principle, it's just copying pixels around in a buffer.
And this involves the use of assembly.
Yeah, exactly, to make it efficient.
Got it.
That's basically, there went a bunch of tricks into that algorithm to make it more efficient. But yeah, in principle, conceptually, it's just copying around the color of a single pixel.
And so, because I saw you put out some code for this. There's the storage thing, which I think is interesting to me, and I think people should pay attention to that. We could talk about that, but this I think is more foundational because this is just rethinking maybe how you think about this stuff. So I saw the code you wrote. I understand you used the dynamic buffer thing from Solidity, which I actually did some contribution to. So I was part of this in a small way. But is there something in your
what dynamic buffer? Sorry,
there was like a dynamic buffer library that you wrote that credited, or someone wrote on your team that credited Solidity's dynamic buffer, which is another library, and that library I had
no, that is the thing, the scaling routine. So we have a scaling in there that scales bytes, the base 64 encoded stuff directly. That was based on Solidity. The dynamic buffer that we have in there, I think that originated from the Strange Tractors project that I mentioned earlier.
Got it. So it's a base 64. So it's a base 64 aware dynamic buffer thing. So you can logically add. Is that so? I guess just to back up a second. Is there a way? Okay, you're out there. You're a kid out there trying to get his or her start, or they're starting blockchain. You have a 24 by 24 or 42 by 42 yourself. Let's call it 24 by 24. I'm a punks guy. You want to scale that thing up. You have the bytes. They're coming straight from the punk data contract. Is there a code in your GitHub repo where I can just pass in these bytes and it spits me out my goal here, or do I have to do more work?
No, it's totally that. Maybe one routine is missing. Let me check. So we have I think the thing that you need basically two libraries here. One is the image library, and the second one is the BMP library. The image library, basically, you can use that to scale the image. We have scaling routines in there, and then you just append that to like your BMP buffer, and that's basically it. And it's all based on the dynamic buffer that we are providing as well. But in principle, what you could do is just look up the rendering contract that we have for the Moonbirds, and there you will see we have like our assembly contract basically, which pulls the data from somewhere on chain, assembles them together, and gives me back a stream of bytes that is just the pixels. And that stream of bytes, you could just replace that by anything else. Could be your punks pixels basically.
And I then you reorder it to green, blue, red though.
Yeah, you have to invert that. Yeah.
No.
But that's basically it. You just have, once you have the pixels, you just have to switch the color channels and then pass it on to whatever we are doing in our rendering contract. You can just basically copy paste the whole thing.
And so on GitHub, like I'm just telling everyone out there, go to divergencetech/ETHIER, which I'm told is pronounced easier. And
yeah, it's easier with the Lisp.
Ethier. It's a very cute. It's so Ethier/contract/utils in that. Okay, sorry. Just anyone listening, just go to this. Just to really nail it down. If you're interested in this, right now I'm seeing BMP.sol, dynamic buffer, image, monotonic. I don't need that. Owner possible, don't need that. Raw data. May be relevant. So where do I go in there, or do I have to go to the chain? Is there anything in here that
let's go somewhere else. I think let's go to Etherscan and have a look at the renderer for Moonbirds, because there you get the broad overview of what is happening. I can send. Do you have the link handy?
I do not.
Then I can send it to you.
Maybe a tweet.
If you go to the Solidify repo, which is the one that I posted in my tech thread, it's github.com/proofxyz.
Yep, Solidify. Yep, this is about the storage aspect.
Exactly, that's about the storage aspect. And if you go to examples Moonbirds,
okay.
I haven't merged it yet. You have to switch the branch to extend Moonbirds README.
Oh, sorry. Nice. Extended README. Oh, yeah, here it is. Okay.
Yeah, well, that is a bit of a work in progress. So I'm slowly catching up on like extending documentation to really like explain properly what's going on. I mean, this is the raw layout of everything. So here you have a bunch of addresses where we deployed the contracts to. The last one on the list is the Moonbirds in-chain renderer. If you follow that link, you should get it on Etherscan.
Yep.
Exactly, and I think if you go to the code window, it should be.
Yep, I got assembler, asset storage manager, Moonbird auth, Moonbirds in-chain renderer. That sounds good. And then
Moonbirds
background registry.
Yeah, it's the Moonbirds in-chain renderer. That's all.
Okay, and then in here, there's the function of my dreams. It's called append artwork URI or wrap metadata. Sorry, everyone who's not following this. You're going to listen to this recording and you're going to learn a lot. And so we're putting it on tape. Okay, sorry. So where is it in here?
Let me look it up. So if you go to the wait, let me see. Let's go to the what is the most simple, because I have a bunch of different functions in here that provide interfaces to remix these outputs. And so, for example, if you're not interested in scaling, you can just go to artwork BMP, that function.
Yep. Okay. Gets the pixels.
This is just the bitmap wrapper, which gets a bytes array, which is just the pixel BRG and BGR encoded. Yeah. Then you have the width and the height of the pixel of the frame.
And this puts like the header on it and just like wraps it up, base64, whatever. Base64?
No, it's not yet base64 encoded. This is really just the header plus the pixel stream with some padding, because like BMP assumes some padding on the data, and this adds these empty pixels.
Okay, so that's super useful, right there. If you just have the pixels, so this is how you could turn that on almost, no, not identically because of the RGB thing. Whatever, you can turn that on to the punks, and then the scaler.
Yeah, exactly. This is without scaling. This is without scaling. If you go one down, you have artwork URI, where you can basically input a list of features, a list of mutators, and a variable scale-up factor. That is, so first, using the features and the mutators, you assemble the artwork, get the pixels back again. And then you compute some padding, you allocate a buffer, and then it goes into this append artwork URI thing. And the trick there is that I had to split it like this, because like usually what you would do is you have your pixels, you scale them up, then you base64 encode it and ship it out, right?
Yep.
That's the logical approach that you would take. But the problem here is that you would have an intermediate copy where you have your scaled up pixels plus the encoded pixel at the same time in memory, which is really memory heavy, and the gas allocation costs scale quadratically with allocated memory size. And this gets really a showstopper at some point. So what I did here is I reversed it. So I had my 42 by 42 pixel image, and I base 64 encoded that, which means that every pixel now has 4 bytes instead of the 3. And then I scaled that up directly.
Wow. So just let me repeat this. This is like by the way, when I was asking, is it just naively going and duplicating? And you were sort of like, yeah, well, this is it's not so naive now because the constraints. So basically, the idea is, in general, with computer stuff, you want to work with the most, legible, intuitive data format, which is like an array or whatever, just like in your head. But then you want to, encode that to something that's more convenient for another purpose, like transporting it or storing it or whatever like that. Expensive in this case, and base 64 encoding in particular in Solidity, even if you're just doing a bunch of that, like anyone working in the most basic on-chain stuff knows that that uses a lot of gas. So basically what you did was keep it in this, optimized format, this less convenient to work with format, and then scale it up in that same format so that you do not have to ever exist in a situation where you have a giant scaled up non-base 64 thing.
Exactly.
So that's pretty, tricky and good. And I hope to be able to copy this. So in your so looking at this function, right? It assembles the artwork from the Moonbird specific stuff with the features and so forth, and then it gets back bytes. And so if I just have my own bytes, I can rewrite this and just say, give me the bytes, and then I pass in bytes, I pass in scale up factor, and this will spit out a BMP basically.
Yeah, exactly.
Base 64 encoded BMP.
It's a base 64 encoded BMP. Exactly.
Wow. And I could theoretically just slam that into a token URI and then basically encode that, I guess.
You can just copy paste that. As you can see, this append artwork URI function is reused in the wrap metadata function, which is used in the token URI.
Wow. Okay, anyone listening to this, just, and look, I know this is like not the first to do it or whatever, but like pretty good stuff here. I'm pretty impressed looking at this, how easy it would be to steal this. Just copy and paste it as I will do. I encourage everyone to steal this. Sorry, I'm saying steal in a provocative way, but like just, this is really great stuff, I think.
It's MIT for a reason. So like the code license that we chose for this is MIT, which is for the people that don't know, it's a really permissive license that permits everybody to do anything they want with it, but they cannot sue us.
Darn it! I was just writing up a letter on that. It's good to just go and sue. But yeah.
The reason for that is because we want that people use that and use it for something else and build their stuff on top of it. So we really encourage everybody to do whatever they like with that code.
And so one request I would have is, can you build a version? Maybe someone out there can do that, or maybe I'll figure it out, where it just takes the normal order RGB and then does it, or is, I guess, making that trans. Yeah.
Just write an intermediate conversion function, I would say, because
okay, fine.
I would do just that, because if somebody else would write that, they would also just do the same. They would just convert it under the hood and pass it to the same routines again.
I don't want to convert it, but I'll figure it out. Okay, so taking a step back, just jumping on the other side and completing the picture. So one downside to BMP is that obviously being easier to classic code data things. So there's less code required to work with it, but it requires more data because it's stored in this pretty naive way, and you can manipulate it in a naive way. Now, if you look at a file format like PNG, which was invented a lot later, and I don't know all the details there, but it's like I understand pretty complicated. Now, you want to store something in PNG, it's really small, and PNG is lossless, and you can store all kinds of stuff in it, pictures, text, everything. So the ideal would be, if you are uploading something to a contract, to upload it in PNG, because it'll be really small. But unless you want to convert from PNG to BMP, then you're in a lot of trouble because you can't get the BMP output that we're interested in here. And I would guess if you want to get PNG output, scaling up a PNG is probably some really complicated thing. So, PNG is kind of off the table. Is this kind of the right way to look at it?
No.
No.
This is actually exactly what we did.
What? I'm in shock.
So the main difference between PNG and BMP is that the pixels in a PNG are deflate compressed. So deflate is a compression algorithm that was like invented someone in the, I don't know, 90s, blah, doesn't really matter. But it is used to compress the pixels, which is why the PNGs are so much smaller than the PMPs. Yeah, and we actually use the same compression algorithm to store our data on chain. And what we are doing in the storage manager contract, we pull this compressed data from contract storage basically, and inflate it again. So we uncompress it and then we hand it off to the assembler.
So let me ask this question: PNG. Okay, so deflate, just for everyone, as I understand deflate, the idea is if you have the letter A 20 times in the row, you should not write out A 20 times, or rather write A once and then the number 20 or something like this. This is the idea behind deflate, roughly, or no?
Basically, so you still have, it's not really run length encoding as far as I've understood. You have because I didn't program this out, this was already available. So you leave these 20 A's in there, but assign it a symbol. And the next time you have to write these 20 A's, you write that symbol instead of the 20 A's.
Got it, right. So run length encoding, right? That's the most basic. You just look at the runs and the length, but this is sort of the same idea, but it's different. Okay.
It's a compression algorithm that, like, when you have repeating data in there, it just compresses it down to like some abstract representation that like enables you to not have to rewrite all that redundant data. You just say it's the same as before, just get with it.
Right. And of course, all compression relies on some notion of redundant data, but if you look at something like JPEG compression, it is,
exactly,
as I understand it, like way more like out there and complicated than just looking at like stretches of repeated stuff. You have to look at like, I don't even know. So it looks like PNG is much simpler than JPEG when it comes to compression.
Yeah, as far as I've understood, yes.
And so, I guess I thought PNG was more, because I thought GIF, sorry, everyone out there, I thought GIF is RLE, and I thought PNG was something more like special, which I guess it is because it's deflate, but still fundamentally kind of similar to GIF in this regard, or am I mistaken? Yeah,
it's similar. I think the exact algorithm is different. I think it's LZW or something for GIF, and it's deflate for PNG. Don't ask me about like the differences between those two algorithms, because I frankly don't know.
You don't know every detail of everything? I'm shocked. So
no.
You don't have to, let that be a lesson. You don't have to know every possible thing to successfully do in-chain stuff. So you didn't literally use PNG, i.e. drag and drop a PNG from your desktop, but rather you took in pixels and created a quasi-PNG in the form of deflated bytes that were stored somewhere.
Exactly.
So you functionally made a PNG, but you weren't actually dragging and dropping.
Exactly. And this is where the Solidity library comes in, because that was really handy for like, this is like a pipeline library, or like it provides a lot of helpers to group your data together, put some indexing and access patterns on top of that, because like you cannot just put data together, because then you don't know where it is in that like really huge blob. So we have to put some additional indexing metadata in. And this is all done in Solidity now. So we have this like huge blobs with a lot of data with indexing in it, and then we compress it, we deflate it, and write it into smart contracts. That's basically what we're doing. Yeah.
And so with that library, Solidity, can I, as a user, getting my start in chain, can I, as a user, like, what's my interface to that? Like, can I drag and drop something in here? Like, being able to drag and drop a PNG would be ideal, but like, I have to like use code.
You have to no Go. So it's a Go library, and you have to write it in Go. So
you cannot use Solidity unless you know Go.
More or less, yeah. I mean, you can. We like, somebody could put like a GUI on top of that, or something. I guess.
But even absent a GUI, at least to be able to program with JavaScript, though, the language of the people, no?
No, Go is becoming the language of the people. Go is actually much more fun, in my opinion.
Yeah, I guess it probably has a better name for like flattening an array. Can you flatten an array in Go, or is that some super arcane thing?
Everything is already flat.
There's no nested arrays?
Well, yeah, okay, well, there is. Yeah, no, there's. I think there's no built-in way. I mean, you would just go through it and depend all the things.
Oh my
with
God.
each other.
Okay. All right. I'm becoming sweating profuse. Okay, it's fine. So I guess last question I have with the Moonbirds thing and in general, right? Another data storage issue is just saying, okay, what are the traits, right? So I've been working on some CryptoPunks projects. I'm a big CryptoPunks guy, and with CryptoPunks, if you very naively look at it, you can say, hey, there's about 10 traits, i.e. 10 mutually exclusive things. And each trait is, each trait potentially can have, 8 bits, although many have less. So let's just do 1 byte per trait. Okay, so 10 times 8, that's 80. So we have an 80 byte thing that represents each punk packed. And now we have 10,000, and 10,000 times that ends up being like kind of, even with SSStore 2, kind of a lot. And so there's smarter things you can do there, but just like storing all of the defining characteristics, not even the images, just like what defines each one.
Yeah.
What's any tips there?
But we are basically doing the same. So we are calling this like set that defines a punk or a Moonbird. We are calling this features or DNA, whatever. So what we are doing, or what we can do with Solidify as well, is we can put together all these features, put again some indexing on top of that, and deflate that as well. And this is basically what I have done using all the 10K feature sets. And if I did this for like all 10K, put everything together, compress it, write it out to the contracts, it would take about 0.4 ETH to deploy.
Got it. So my version, where I just say naively, okay, 80 bits.
Yeah, we had 7 bytes.
10K, so that's 800,000 bits. Whoops. Times whoops.
It would be about a factor of 10 more than us.
Right. So yeah, that's 780 kilobytes, right? Almost a megabyte. Okay, that sounds not so good. And you're saying you can get that down, but you have to store it in a special way, right? You can't just say, hey, like just using integers. You have to store it and you have to do that. And so your library, if you know Go, handles the images and the features all RLE in them.
Exactly, it handles all generic data blobs. You can do whatever you want with that. You can store videos, you can store sounds, you can do whatever you want. It's really generic. It just gets data blobs, puts some additional indexing on top of that, and compresses everything.
I mean, it's funny, right? Because like code versus data, it's like, hey, everyone out there, if you want to save a ton in gas, all you have to do is hire CX Coda and have them spend a ton of time, on this. You'll save a lot of money that way, actually. So it's like the amount of work required to get this gas savings, but now maybe it's free for me or whatever. But just like,
but
it's incredible.
it's again, it's not that I'm the first that is doing that. Like for example, Watsy did that already for the on-chain toads, so cryptodes, and. Like I'm conceptually doing really, really similar things here. I'm definitely not the first to like have this idea and do that. What I'm doing here first is doing the on-chain scale up and bringing the whole thing into a framework that is much simpler to do. So once you have like the knowledge to operate in like the library in Go, you can do that without any other problems. You don't need to do all the things manually as you had before. That is the contribution that I made here. I did not come up with the deflate stuff because that already exists. All that I did here is to make it much more convenient, more efficient, and more straightforward to do. And the on-chain scalability thing. That I think
PFP,
I was the first.
The first legit PFP that is in the hex that's on-chain.
Yeah.
Chain, whatever. Yeah.
Exactly. Yeah. That's the first. And I think I was the first to do on-chain bitmap scale up. But like always with the first thing, if you look closely enough, has always been somebody that did it before you. So I'm really cautious with I did something first part.
This is the first ever on-chain PFP project. I'm calling it that because I really I have so many regrets about SVG stuff I did. Okay.
Yeah.
This has been an amazing primer. This is going to be an amazing podcast. This will be listened to a lot, I think, closely by people who want to learn how to do this, by me also. Is there anything that you would have done differently, that you wish you had done differently? Any gotchas, any sort of little, like, okay, you've been there before, like what's the tips and tricks kind of thing? Like what could have gone better, that kind of thing?
That's a good question. Not yet, I would say, because like I'm still in the honeymoon phase with my project. I still don't see the faults. I think that will come when I revisit the code in like a month or so.
All right, well, I'll have to check on you then, but I think you deserve it.
But
so yeah, start to finish. What was this?
Yeah. Do you know that phase? Like, yeah, does it happen to you as well? Like at some point you just don't see the flaws anymore.
Yeah, I even had a literal honeymoon. I didn't exactly have a honeymoon, is the truth, but I've gone through, I because of COVID or whatever. But yes, I the rush after releasing something that anyone starts to use. With me personally, I've always developed around the idea that no one will use it. So as soon as people start using it, I'm just kind of like, okay, I have to now fix things, which is not really possible on the blockchain itself. So it's the front end for me that's always the the big challenge. But I think I've had pretty good. I don't know. We with the great focus on punk. Derivatives, and with the punks, there's always like a lot to, learn. And there have been some issues where, Dov and I got a pixel wrong in a punk derivative that doesn't look right. And so these things have happened, but I think it's always a very big rush to have people use a new thing. And so I totally get it. How long did this project take for you in terms of the Moonbirds aspect, specifically start to finish?
I think I started at Proof in August, I think. Yeah, I think I started in August. And I think I started working on that project somewhere in September. So a bit more than 2 months. But like in that time, I also worked on a bunch of like smaller things, I would say. And you know how it is. But like roughly 2.5 months, start to finish. Cool. And now that I'm thinking about it, there is one thing that I would do differently if I had the time. But I mean, it was a conscious decision in the end. So, like what I did with the data is just I took all the layers, put them together, and deflate compress them. But there is actually something more efficient that you could do, like a bunch of layers for like the bodies of Moonbirds or other traits or other layers. They're really similar in terms of their shape, and everything that basically changes is the coloring. So what you could do here is to store just one template for the shape and another like string or so, like a string that encodes the colors that are used for every different thing. And I think with that you could get it a lot smaller even.
Well, that's interesting. That also reminds me then, like in terms of just general compositing issues, like if you wanted to not duplicate an existing known collection, but do something more generative, right, where you had the traits and, they generate stuff from it, you might have traits that have transparency in the traits. So, for example, in the punks, you have the horn rim glasses, which are glasses that are semi-transparent, and the glasses themselves can be over a mole or spots, which is also semi-transparent, and that's over the skin. So the flesh, so that creates a double, it's a sort of two transparent things on top of each other. The final thing, of course, is not transparent against the skin. So if you're trying to composite these layers in, in real time, how do you do that? In the Punk data contract, they actually store all possible composites in the contract. So so if you ask, what does this layer look like on top of this layer? It says, is it opaque? Okay, then take this thing. If it's not opaque, look up the composite color from this other data store. That's not such a scalable solution.
No, I'm doing really the alpha blending here. So I'm storing all the layers with alpha channel, and I am doing the alpha blending when I'm assembling all the layers together to get the final image.
And so that's in the renderer too?
Yes, that's in the assembler.
That's in the assembler.
Or if you go back to the Ether library, it's in ether/utils/ image.zone.
Let me look at this right now. Image.sol. And the you're starting RGB thing. Okay, and then you alpha blend. So what is there? There's like, I guess there's a math formula for saying like how you blend alpha stuff together.
Yeah, exactly. There's a bunch of different ways to do that, and there is a like accuracy focused algorithms or fast algorithms. Yeah, there's a bunch of different algorithms that have different drawbacks, but that was the formula that I used, because using that formula, you would pixel perfectly reproduce all the assets that are out there. And I really did that. So for my renderer, this is really validated against all the 10,000 images that we had before off-chain.
Well, and how do you do that validation? Hash it?
No, I had I did pixel perfect comparison.
So you just went pixel by pixel and kind of looked, was it the same pixel? So then you were using the quote unquote correct alpha thing, or just at least the same one?
Exactly, yeah. It's I mean, as far as I've understood, this is the most accurate one because like it does the proper linear interpolation between the two things. But what like essentially mattered to me that it's the same that they used when they generated the assets.
So how can you have the most accurate one? Like, what's the standard under which that's based, and then why not just use that? I guess it's too expensive.
I think I think that is the standard actually, but they are more like there are approximate alpha blending routines that make some assumptions or like do some rounding differently and give you approximately the same result as the correct one. But
that is an amazing technique for being the most accurate. Is just have you be the standard for accuracy, and then you're golden. So I approve of that, and that's very cool. So I can take a look at that. So it's actually kind of a lot of work to integrate this in the end, but I think it could be very, very cool. And if you're out there, you're listening to this, and you do an on-chain project, and it's not in the hex, you have no excuse. So get to work. This has been a super great conversation. I would guess that I have talked a lot. I don't remember, but does anyone have questions for our distinguished speaker? Because if you don't ask it now, you will regret it.
I have a question.
Go ahead.
For the GM Studio project. For the GM Studio project.
Yeah.
You clearly care a lot about preservation of it, which was also how we started with Capsule 21.
Mm-hmm.
Do you have a concrete idea about the time frame? What are you thinking of in terms of preservation?
What exactly do you mean about like for the time frame? What do you mean with that? Like for how long we are aiming to preserve it? For preserve it?
Indeed, yes. What kind of ideas do you have about that? Is it like 100 years, or how do you see that?
I think since most of the stuff is based on JavaScript, and JavaScript like changes quite rapidly. I mean, I don't have any data for how fast packages that have been hosted on NPM really disappear and never see the light of day again. So I'm not too knowledgeable about like how long it usually takes until something is not really can no longer be replicated anymore. But I would say with stuff that has these kind of code dependencies, it's usually like I don't know, 50 years or so. Would be my guesstimate. But I'm not really too knowledgeable about these kind of time scales or how to like estimate them. Let me pass that question back to you. What is your what did you think with Capsule 21?
Well, it was a bit of a meme, of course, but we said we want to make it for the aliens.
Okay.
So they can still see it. Like you also have this disk they send in space.
Uh-huh.
So it's not concrete, but it was these kind of ideas that we were thinking about. So I wondered if you also had that kind of
with JavaScript.
No, not with JavaScript, but more in general with the on-chain ID.
I mean, in principle, so I mean, there's two different things going in here. So there's like how long can the file format itself live? So how long can the knowledge survive that is required to interpret whatever you're storing, and how long living is your storage medium? Like, I think people will be able to interpret it to interpret a BMP much longer than they will use the Ethereum blockchain. For example,
Really?
I think so. I think so.
Cryptocurrency. I'll be right back.
Pardon?
I said I have to sell some cryptocurrency now. I mean, is that? I guess BMP has existed way longer so far.
No, I mean just from like historical data. What kind of software product has lived longer than 50 years or 20 years or whatever? I mean, the Ethereum blockchain is great and all, and it's really great and everything. But I am sure that in 10 years' time, something better will come around.
Wow.
Or in 20 years. I mean, maybe that is too pessimistic for me, but I think like with past things, something that has been on the top has never stayed on the top forever. I think that is something that we can really extrapolate from like history. And I think the same is happening with Ethereum as well. I think it would be naive to assume that it will be around forever.
Yeah, well, forever, I think, yes. Nothing stays on top, forever. The Earth itself, even
exactly.
Again, the ability to interpret Ethereum is also
the existential crisis part of the podcast,
related to my ability to be alive too. It's like, yeah, there's I think people have to be there to do it. I think the kind of question is it's sort of paradoxical though in a sense, because anything that is trying to supplant Ethereum will have to itself make claims about longevity, and it will have a worse argument to just it's the whole blockchain thing is it's just quite new. But definitely BMP has, if you're looking at how long something's going to last, if you want to assume you're at the midpoint, or whatever, that whole thing, then BMP is going to be around for quite a while. When was BMP created? I'll look this up.
I think it was in the 90s that it was standardized.
Well,
but it has been around for longer, I think.
This is the premise of the art project that I did called Moon Lake, which is essentially just an educated guess that PNG will not be around eventually. Like eventually the PNG file format is going to be gone.
I agree, because like PNG is based on a compression algorithm, and at some point we will find better compression algorithms.
Right, exactly. Yeah, so that's most of this conversation, really all of this conversation has gone over my head, but I think that is really interesting to think about, is the deprecation of technologies, and like Ethereum itself. Like I agree 100% that everything is going to change in 20, 30 years. You won't have Ethereum, or Ethereum might still exist, but it won't be the best thing, like you said.
I think like the interesting thing with blockchain that hasn't been there before is if you as a collector, or if a bunch of people value something enough, blockchain technology enables you to unilaterally keep that thing alive. So as long as enough people care about something, they can keep it alive, because there is no central entity that can fail. So it's always if the community, if like the users or node providers, or like if like a group of people cares enough about something, they can decide to keep it alive. That is like the fundamental, one of the fundamental benefits that blockchain technology provides. And if something better comes around, then of course you can migrate it over. It's just a storage medium here.
But but to me though, it's that the property you described is the centralization property, right? It's something with a shared IPFS. It's just no single point of failure. If anyone who has one of the original Moonbirds, the off-chain ones, if anyone wants to keep that alive, they can do it. Any number of people can do it. They can have it. With the blockchain thing, right, is that everyone who uses the blockchain has to admit that Moonbirds are there. and so with IPFS, you can use IPFS, but you don't have to admit that my thing is on IPFS or that my thing is valid or whatever. And so, that extra property, requires people to want to use it, because if people don't want to use it, they won't have to admit it. And so that's why it's like kind of this scary idea. Of course, I agree, but it's a scary idea because if anyone, you want people to be forced to say your thing still exists, not just to not be able to destroy your thing, because there are so many things that, are undestroyable. You could bury something in your yard and carve it in stone and, all that kind of stuff. Probably it's going to be pretty tough to destroy, but I want people to admit my thing exists, So anyway, we'll see if it lasts forever. What is, speaking of forever and the next thing, I don't know about proof and everything, and you maybe just, can you give us any idea? It could just be like what you're going to work on next, or maybe even what an area is that you think is exciting to work on next. Like, what does the future hold, in the next, not 50 years, but a shorter time span for you and your work?
Interesting question. So for me personally, something that is on my roadmap for forever now, but I have never had the time to really explore it, is the entire world of zero knowledge proofs stuff. This is right now moon math to me, because I don't really understand it at this point. Like I haven't read up on it, and I'm lacking the mathematical basics for that and how that really works under the hood. But that is something that I think will be very, very interesting in the near future, and I would very much like to dig deeper on that front, because I think that is one of the most interesting technological advancements that I have seen, like in the past couple of years. I mean, it has been around for longer, but it's now being popularized, and that is really exciting to me.
Oh, very interesting. So one of the use cases for this, right, has been L2s, right? Is there any particular use case that animates you, or is it more just like the technology and the possibility?
I mean, they're like, I'm really not an expert on this, and so take everything with a huge grain of salt. But as far as I've understood, there are like two main, or like there are definitely more, but these are the two use cases that I've seen. One is data or compression of a computation, so that you can prove that you have done some kind of computation, which is like what the L2s are using, because they're proving that they like validate all the transactions in a certain manner, and then everything in there checks out. So they use it as a compression method, but you can also use it as a method to share like a statement, prove something to be true without revealing your underlying information. So for example, if you ask me if my bank account balance is greater than 10 euro, then I can prove to you that it is higher than that without actually revealing my balance to you. That is what you can do with zero knowledge proofs, for example. And that for me is really intriguing, because I have no intuitive way how to like explain somebody how that is supposed to work. But it works on a mathematical level, and it's really neat, and I would like to better understand that.
Right. I guess another way of formulating it is like you can ask me a question and I can give you an answer, and that answer would only be possible for me to give if I knew X piece of information that I'm not sharing with you. And
exactly.
It's like computation. It's too hard for me to answer this question in the time span of the universe unless I had this other piece of it. Yeah, I think that's that's a very interesting, intuitively compelling concept. I think that's good.
I think there will be a bunch of like other technology that will be built on top of that. And that's why I'm thinking that this will be a good like tool to study and to be capable to work with. Because I think that will be around for a while now.
Love it. Cool.
Yeah.
All right. Well, this has been an amazing conversation. Thank you so much. We'd love to have you on again when the next, and we didn't get to the haters, but I don't even want to talk about the haters. We've gotten that, but just, whatever comes next drops, like, we got to talk again. Cause like, I really am a huge fan you and your work, and you are impacting a lot of people out there, even if, just you're impacting a lot of people out there positively, people trying to learn to do better with this stuff. And I'm personally going to take a very close look at this episode, go back and dig. I encourage everyone to do that. Usually the Capsule 21 podcast is recorded live Thursdays at 5 p.m. Eastern time, but when there is a luminary involved, we will bend the rules. If you are listening to this, if you're a luminary, don't get any ideas. We prefer to stick to regular time. So just